Guides here, everybody, or Creole, as some of you know me on the Unity 2D subreddit. Today we're going to be looking at the free asset project that I created for the month of February, the FAP of February, as I like to call it. So let's just kind of jump right in and kind of look at what it was that I created. So if I hit play, so we have a random character from some random game. He's just kind of walking around, and whenever he walks, he's kind of facing the correct direction. When we leave him off at. So he's idling if left, up, right, and likewise the animation is playing correctly. So if he's walking upwards, it's an upwards walking animation. Down, it's a downwards, left and right. If I click my player real quick and click the animator window, it'll look like as if I only have 2 animation clips, and it's not entirely true. If I move around, you see that there's some parameters getting worked on over here, and yeah, so let's kind of look into the system and see what it was that I created. So we're going to kind of start from scratch. Before we jump in, I just need to let you know this is going to be more of an intermediate tutorial. So if you're new to Unity, there's going to be some concepts I'm going to gloss over. So if you've never created a game, I always highly recommend creating Pong. But some of the stuff I am going to kind of gloss over. So feel free to hit me up in the comments area over in Unity, on the Unity 2D subreddit if you have some additional questions. But yeah, for this particular video, I'm going to kind of try to speed it along. So let's go ahead and start from scratch, and we're going to hit File, New Scene. And in the scene, let's go ahead and just quickly drag in a sprite. So we have it in our camera. I'm going to make this camera size just a little bit bigger or smaller, whichever way you like to think it, so that kind of our character fits in there. I'm going to double click it so he's in the scene view. All right, great. Let's go ahead and call him, give him a name, call the sprite player. And the first thing we're going to do is we're going to be using rigid bodies. So let's go ahead and add a rigid body, 2D. And if we hit play real quick, we'll see that our player is falling down. And always when you're making things, always make sure you're testing frequently. Don't try to code whole systems and examples and then hit play and hope for the best. Always do little bits at a time and hit play and make sure things are working. So now we've created that, we're going to actually, the first thing we're going to do is actually we're going to get our character to player to move around. And before we get into the animation stuff, we need to get our stuff set up so that we're recording how it is that we're moving our player around, because that's going to feed right into our animation system. So let's create a new script. So create new C# script, and we'll call it player controller. I'm just going to call it tutorial for this case. So let's go ahead and open that up. And we're going to create a function, or add the function that's built into Unity, void fixed update, because this is where we're going to be adjusting our physics, because you should be always adjusting physics in the fixed update function. First thing that we're going to create is a public float. We'll call it move speed. And likewise, we're going to create a private vector2, and we're going to call it player movement. So with that created, what we're going to do is we're first going to get the axes. We're going to get the our actual input, our actual player input. So how we're going to do that is we're going to say in our update function, we're going to say player movement is equal to new vector2, and that's going to be input dot get axes raw, and that's going to be horizontal. Now, get axes raw is a very interesting kind of method. I do recommend you read up on it. I'm not going to explain it in full, but essentially, it's going to get us absolute values instantaneously. So as soon as we hit the left button on the left key of our horizontal button, it's going to give us a value of -1 right away. If we hit right, it's going to give us a value of 1 right away, and if we're hitting nothing, it's going to be 0 right away. Gravity sensitivity of the input manager is not influenced at all. Again, sorry, I'm kind of glossing over some of the beginner stuff. Do read up on the input manager, how the input manager works. Documentation in Unity 3D is totally awesome. So look it up, look up what the input manager is, and then look up what the method of get access raw is. And to look that up is, copy that method, go into help, scripting reference, and then just paste that method, and you will get in documentation right away. It'll appear. Generally, you'll have a code example for you showing you how it's used, what it's used for, that sort of thing. Give you an example to actually put right into your game. So that being said, let's go back in. So input dot get axes raw, and we're going to say input dot get axes raw vertical. So that's created player movement. And now we actually want to act upon that player movement. So what we're going to do is in our fixed update, we're going to say rigid body 2D dot move position. Again, if you're not familiar with move position, look it up on the online documentation. And we're going to say rigid body 2D dot position plus player movement times our move speed times time dot delta time. So what this is going to do is it's going to allow our player to actually move around. So if I go back to my game, click and drag this script right onto the player, and then go ahead and hit play. Actually, it's not going to work just yet. Let me go to player. I have to actually set a value here, so let's set it to like 50 for the movement speed and hit play. I can now move my character around. That's awesome. That's great. So now let's work on the actual animation. We have our input. It's kind of simple and easy. We're going to be using those values for our animation system. So obviously, to create an animation, you need animation clips. I've created all these. These are very simple animation clips. All that they have in them is just that animation movement. So if I go into my sprite editor and look at my sprite real quick, zoom in here, you'll see that there's a walking animation for down, for left, for up, for the right. So all those have already created and they've put into animation clips. So create your animation clips like normal. And what we're going to do is we're going to create a custom animator. So in our project view, we're going to right click, create animator controller. And if you already have an animator controller, you can go ahead and use that. It's kind of easier if you have one from scratch because we're going to be doing some special things with it. So that you don't have any issues with it, make a new one like this. So let's say a player animator. We'll just call it that. So on our player, let's create a new component, add component. We'll add the animator component, and we'll click and drag that object created, the player animator object, and click and drag it into there. If we hit our player now and click the animator window, we now have that blank animator slate to work out of. So we're going to create states. Instead of clicking and dragging clips into here, we're actually going to create states. So let's right click, create state, and we'll create an empty. And then we're going to name that empty idle. Now let's create another one, and we'll call it empty. No, excuse me, not empty. We'll create a new empty one, and we'll call it walking. So that having been created, let's create some transitions between it. Just right click and idle, make transition, click on walking, then right click on walking, make transition, and click on idle. Now we need some kind of way to tell the animator, I want you to go from the idle animation or the idle state to the walking state, and then from the walking state to the idle state. So let's create a new parameter down here, and we'll create a bool, and we'll just call it walking. So if we click the transition itself, and in the condition, we can set walking now. So if walking is true, go to the walking state. If you go from, if we're done walking, walking is false, go back to the idle state. So we need a way to actually influence that Boolean in the animator. So going back to our script, we're going to create a new variable, and we will call it private animator my animator. And then in the start section, we're going to say here my animator is equal to get component animator. And what that's going to do, again, look up in the code, in the documentation, excuse me, is it's going to look at all the components that are attached to the object so the script that The object that this script is attached to, with this code, it's going to look at all the components that are attached to that object, and it's going to pull the specific one that we're looking for. So we're looking for the animator controller that is a part of this game object, and we're going to feed that into my animator. And so we're going to adjust that my animator. We're going to tell it when it's walking or not. And to do that, we're going to go into our update, function, and we're going to say if input.get button. So if we're pressing the button, doesn't matter if it's down or up. Well, actually, I mean, it's being pressed down, input get button. If that is true, the button that we want is horizontal. So if we're pressing horizontal, regardless if it's at the positive or the negative value, we're going to be getting that button. Or if input.get button vertical is being pressed. Let me put that over. Let's go ahead and close this if statement and save it. So we're saying if input horizontal for touching the horizontal buttons or for touching the vertical buttons, we want to access my animator dot set bool, and we're going to say walking and make that into true. So now what we're saying is if we're walking, set the walking bool of our animator to true. Go down here, else. So if that's not happening, we're going to say my animator dot set bool walking is false. So now if we go back into our game here real quick, again, always test in little increments, hit play. Now when we walk around, we'll see that whenever we walk, the walking boolean turns true and the walking state starts playing. And when we let go, it transitions back and goes to idle. Walk around, stop walking. Awesome. And I didn't save the scene, so let's save it. So now, sorry, just taking a quick look at my notes. So the next thing that we want to do is we want to actually start getting our animations into here. So before we do that, we want to actually feed our input into the animator. So we already know that if we're pressing left on a horizontal, if we're putting the negative value, we're going to get a -1. Again, read up on Input Manager, read up on Get Access Raw. So if we're pressing the negative value of the horizontal button, it's going to be -1. If we're pressing the positive value, it's going to be +1, vertical, up, down, all that kind of stuff. So we're already getting some values. So let's set some parameters into our animator component, and we're going to hit plus, and we're going to create a new float. Now I'd like to use an integer, but we can't, and I'll explain that a bit later. But we're going to be setting some floats, and we're going to make one, we're going to call it input x, and we're going to create another one, and we're going to call it input y. So we're going to be feeding our horizontal and our vertical movement into our animator. So that's saved. Let's go back in here. And the way we're going to feed this is a bit different. So we're going to create a new function. And we're going to call it define player direction. And we're actually going to feed a variable into this function. And it's going to be a vector2. And we'll just call it input. So now what we're going to do is whenever we call this function, we're going to feed it. We're going to feed it that movement. We're going to say player animator. Oh, excuse me. My animator dot set float. So the input x input dot x. So what we're saying is we're going to set the float of the my animator. We're going to set the input x float, which is over here, input x. And we're going to provide that value. The value that we're going to put into there is the input.x. So basically, whatever we feed, whatever vector2 x value that we feed into this function is going to get put into that float there. And likewise, we're going to do my animator.set float input y input.y. And we're going to actually call this function every time that we're moving around. So in here, we have input if input get button horizontal, if input get button, we're going to not only set that bool, we're actually going to also call this function. So define player direction. You know what? I should spell things correctly. Direction. And we're going to feed it player movement. Now remember, player movement is actually being fed right here with our get axes raw. So we're getting all that x and y value up, down, left, right. Remember that input that we're using for the actual movement. Now we're going to actually feed it into the animator. So if we go back into our animator here, we're going back to our game with the player selected and hit play, we'll see that the values are actually now getting set. So if I'm going input, if I'm going to the left, I'm getting a -1. If I'm going to the right, I get a 1. If I go down, I'm getting a -y. If I go up, I get a +1 on the y value. So that's good. Now we have some values that we can actually use. So let's go ahead and actually set up this animation system now. That's actually kind of more of the tough part. This part's going to be, you have to kind of, it'll be initially hard to understand, but once you get it going, it's a very simple setup and easy system to use. So with our states here, again, they're not actually animation clips. They look like animation clips, but they're not. We are going to actually kind of put 4 animation clips into each of these states. And to do that, you go ahead and click the clip. You're going to right-click it, right-click the state, and you're going to choose the option Create New Blend Tree in State. When you click it, nothing actually happens. What we've actually done is created a blend tree. And to access that blend tree, you simply now just double-click the idle state. And you have this thing that's called a blend tree. A quick overview of blend trees. I'm not too familiar with them. I haven't used them that much because they're actually more used for 3D stuff. And for 3D stuff, my understanding is that you use them to blend animations together based on whatever values that you kind of throw into it. So basically, you know, maybe a soldier looking around a corner or walking upstairs or something like that. It's blending animations together. So this system's not meant for 2D, but we're going to be using it kind of like for 2D. So to do that, what we're going to be doing is we're going to change the blend type. So we need to be able to tell it both the X and the Y values. So to do that, we're going to change our blend type to 2D freeform Cartesian. And now we have 2 parameters that we can provide it. There's an input X, and the second value we can change it to input Y. And now if we look over here in our blend tree, we have an input X and an input Y being provided by these 2 parameters. Now this is where I was going. This is where I was telling you about integers. I'd rather use an integer if I could, because we obviously are just using a 0 or a -1 or a +1. But unfortunately, with a blend tree, you can't use integers. So if I created a new parameter, created an int, and then try to add it here, it's not going to show up. You can only use floats with the blend tree. So that's what we're going to have to use. So with our player selected, or with the blend tree selected, excuse me, we're going to add our animation clips into it. And I'm going to kind of just add these 4 fields real quick. So we're going to hit plus, add motion field. We get this kind of option that appears, motion. This is not an actual, well, it is motion, but we're going to actually put our animation clip into it. So let's click and drag player idle down into it. And now you see that it's part of that blend tree. Let's hit plus again, add motion field, and this box appears. And again, that's more for the 3D stuff, for them to visualize what's going on. It can kind of help here, but it's not really used. It's more for the 3D stuff again. Obviously, we're going to need 4 animations, up, down, left, right. So let's add a total of 4 motion fields here. So now I have 4 motion fields, and I'm going to click and drag player idle left, player idle right, and player idle up. Now, again, when we moved around, if you remember correctly, we had very particular values. So if we move left, we get on input X, that turns into a -1 if we're moving left. If we go to the right, that becomes a +1. So we already kind of know the values that we need to set for X and Y. And likewise, if you look on the motion field, you'll see that we have position X and position Y. And we're going to set it to exactly match our inputs. So if we're going down, we get what? We get a negative y value of -1. If we're going left, we have an x value of -1. If we're going to the right, we have a +1 value. And if we're going up, we have nothing on the x, and we have a +1 value. And now we get this perfect triangle. And that's what we kind of want to see when we're setting up this system. So that's the idle animation, and that idle animation's been set up. I'm not going to show it just yet because we want to set up the walking animation to make it look correct. But now that that's set up, that's really all there is to that system. You just create a new state, make it into a blend tree, and add those animation clips. So let's look at how it looks like when we create the walking one, because it's literally no different for when you create a swinging sword animation, when you create anything else. So again, in the animator, you'd right-click the state, click Create New Blend Tree in State, and you double-click it, change the blend type to 2D Freeform Cartesian, change the parameters to look at both input X and input Y, add 4 motion fields, 1, 2, whoops, 3 and 4, and click and drag our clips into here. Walk down, walk left, walk right, walk up. And so our walking down animation, that's obviously a -y of -1. Walking left is a -1 for the X value. Walking right is a +1. Walking up is 0 on the X and a +y. Again, diamond is what we're looking for. I might have said triangle before. That's it up. Our animation clip is in there. And if we hit play now, our player moves around and he stays idle in the correct location. And if you see, our blend tree is getting activated. So when we hit -y, -1, you can see all those numbers and all these animation clips getting chosen differently. So if I'm walking down, it's down. If I'm walking up, it's up. So I mean, that's all really there is to the system. You can add a separate state for when you're swinging a sword. And likewise, you just stick in those 4 animations. So there's an upswing, a downswing, left and right. There's all those kind of things. That's all there is really to this particular system. Now, if you go into the Zelda Type 2 project that I linked, it's a tiny bit more complicated. I have a bit more script and code in there. I have that extra swinging sword animation, so you can see how that system is set up. I'm not going to go into details on it, but one thing I will mention on it real quick, just so you can see it. If I go into here and I'm just going to drag this animation clip in here, and then I'm going to choose the animation clip, player swing down. You'll see I have something, this little arrow down here on the animation. Typically what people do when they want to, people regularly ask, how do I know when how do I get the length of an animation clip? And typically what I understand that people ask that for is not because they really need to know the length, it's because they want to do something at the end of that animation, or maybe they want to do something in the middle of that animation. And actually Unity provides you a system to do that with. You don't have to actually calculate the time. You just use events, and you can actually call events from within an animation system. So this kind of bonus, if you don't have to listen to this if you don't want to, this is just a little bonus that I'm adding to the end of this tutorial. So this animation system, you can call functions within your script. So let's create a new function real quick, and we're just going to call it void this is my event I want to use. And in that we would do stuff like that. So let's say at the end of my swinging sword animation, I wanted to actually do something with it. Do something like I wanted to, let's say, in my particular case in the Zelda Type 2 program, or project, I have it when you swing the sword, you can't move the character around, and all of a sudden you can move him when the animation's done. And the way I did that was I made like a boolean in here that was like can move is equal to true, and that's all that particular function does. It just makes the boolean can move equal to true. And then what I did was I'd go into the animation clip, I would click the little plus here, add event. And this little window pops up, and you can choose a function for any script that's attached to that player. And if I click and drag that down, the ones I get are fixed update, and that one I just created, this is my event I want to use. So I click that, close it, and now it's been added to my animation. And with that, I can place it where I want it to occur. So I want it to occur at the end. So that event is going to get called at the very butt end of that animation, and it's going to make it possible for my player to move again after they swung their sword. And that's how you can make events into this animation system. So I hope you guys liked this tutorial. Hope it wasn't too much of a drag with me ad-libbing it and everything and having to see my face. I'm sorry. Probably made some babies cry, but thanks for tuning in, guys, and hopefully we'll come up with a great new project for next month's FAP. If you guys have some suggestions or some recommendations, or likewise if you have any questions, just hit me up on the Unity 2D subreddit. I'm available there pretty frequently. Otherwise, thanks guys for tuning in, and have fun doing game development.